Okay, YouTube, in this video we are going to list the trig values of the special right triangles, or at least the special angles 30, 45, and 60, since we deal with those triangles often. These are values that you will want to have memorized if you are in any trig class or any pre-calculus or dealing with triangles on a regular basis. So a good thing to do is actually make flashcards from the results that we find here. But what you're going to see me do here is we're going to sketch out my 30, 60, 90 and my 45, 45, 90. And we're going to label the sides accordingly from what we know about the relationships between the sides of a 30, 60, 90, 45, 45, 90. Starting with this, we know that a 45, 45, 90 is isosceles. We know that we should always look at the short side first when you look at special right triangles and just give it a letter. So we say, we'll call these both some length A. Well, then we know that the hypotenuse is that length times the square root of 2 is the relationship there. Also over here on a 30, 60, 90, you look at the short side first, we'll call it A, but we know that the hypotenuse is twice as long as the short side on a 30, 60, 90. We know that the long leg is the short side times the square root of 3. So now, knowing all of these values, what we're going to do is we're going to piece together a table of values. And we want to use this table to help us kind of memorize the values of the trig functions. Now I'm only going to go over sine, cosine, and tangent, but we're going to put these special right angles in here. Okay, so you'll notice that I'm actually putting a lot of spots on this. That's because I'm going to amend more later. But we say our three trig functions we're focusing on here are sine, cosine, and tangent. Okay, and we'll say of theta, of some angle theta, where our angles are these things up here. Okay, so we'll put the angles up here, and I'm actually going to put 30 degrees here, 45 degrees here, and 60 degrees here with intent to kind of fill in the rest of the table later. But for these values, let's go ahead and start with sine. Okay, so as far as finding the sine of 30, we would go up here to our 30, 60, 90, we say, well, sine, SOHCAHTOA, we say opposite over hypotenuse. So if we were to do the sine of 30, I can do all my work over here. We say sine of 30, we would get this, we get A over 2A. And the important thing to notice here is that the A's canceled out, and look what we get left with. We get left with this, we say 1/2. So the sine of 30 is always going to be a half no matter what triangle you look at. I should probably write my fraction this way. So 45 degrees means we're going to have to look at this other triangle here, but we say go find the sine of 45 degrees. So we say opposite over hypotenuse. So the sine of 45 degrees, we can write this out here. We say sine of this angle. When I compared opposite over hypotenuse, I got A over A times the square root of 2, which our A's still cancel. But the point here is we got left with 1 over the square root of 2, which I'm going to rationalize. I'm going to take both the top and the bottom times the square root of 2, and I get root 2 over 2. So the sine of 45 degrees right here would be root 2 over 2. Okay, now sine of 60, we have to go back over this triangle up here, but we say sine of this would be opposite over the hypotenuse. And so sine of 60 would be, let's see here, let's write this out. We say sine of 60 would be equal to A root 3, which was opposite our 60-degree angle up here, over 2A. So our A's, again, they cancel out and we're left with this, root 3 over 2. Okay, so one thing I want to bring up is this. So far what we've seen is if you look at the sine of 30, 45, and 60, they all have something in common. They're all over 2, which is a nice thing to help us remember that. Also this, and this is how I kind of remembered it, but in order we say the sine values at least, from 30 to 45 to 60, you notice the numerators, they go 1, 2, and 3. And also this, as a matter of fact, if you're saying, well, it doesn't really go 1 because it's not the square root of 1, well, if I put the square root of 1, it's still 1. So you can put roots on top of all of these, but that's how the scheme for sine goes. Now, what we know about sine and cosine is that they are, we'll list this out here, they are cofunctions. So this means that I don't have to do all of my cosines. I just need to do one of them to show you the relationship here. But when we do the sine of, say, 30 degrees, we went up here, we said opposite over hypotenuse. What if I were to go now and do the cosine of 60 degrees, which, by the way, is adjacent over hypotenuse? Remember, in an acute, or at least in a right triangle, these two acute angles are complementary. And we know that cofunctions of complementary angles, that is, if I did the sine of this, it'd be the same as the cosine of this. Or if I do the secant of this, which is the reciprocal of cosine, it'd be the same as the cosecant of this. What I know is this, then the cosine of 60 degrees has to be the same thing as the sine of 30 degrees. That is, the cosine of 60 degrees. I can even go to show. We say if we did the cosine of this, 60's here, we get adjacent over hypotenuse, I get A over 2A, and so my A's cancel, I get a half. So let's list these out here. We say that this is a half. I'm already going to spill the beans here because I already know this relationship between cosine and sine, that is, that the sine of 30 had to be the same thing as the cosine of 60. I could have just filled these out. So with cosines, you notice they're all over 2, but I'll tell you what, they're kind of backwards. So where we have 1, 2, 3 on top for sine, the scheme is 3, 2, 1 for our cosine values, okay? And then let's get to our tangents, and then we'll fill in the rest of these. But we say tangent value, tangent of 30, let's go up to our 30 here. We say tangent is opposite over adjacent. So I get this. I say tangent of 30 degrees is equal to opposite over adjacent, where those cancel out, and I left with 1 over root 3, which after rationalizing, excuse me, becomes root 3 over 3. So we say this is root 3 over 3. We're going to go do my favorite angle to take the tangent of now, the tangent of 45. Because this is a 45, 90 basically. When you do the tangent of 45, you're going to get A over A. But the thing to point out here is that all 45, 90s are isosceles. And so whenever you do the tangent of a 45, you're going to get opposite over adjacent, where those are the same thing. So you're always going to get 1 for the tangent of 45. So that's a good one to memorize. And then the last one here, we say tangent of 60. If you go look at your 60-degree angle on the triangles we sketched up top, we say 60's here. Tangent is opposite over adjacent. So I would get A root 3 over A, which is just root 3. Okay, so now we filled out this entire table. Really quickly, I want to comment on tangents. The thing to memorize about tangents is that the tangent of 45 is always 1, and that's kind of in the middle. But here's what I can tell you. To the left and right of this, we notice that we both involved something that had a root 3. One was root 3 over 3, and one was just root 3. So the thing I want to point out is this. Root 3 over 3 is smaller than just root 3 because we split root 3 3 ways, so it's smaller. So the root 3 over 3 is always going to go with our tangent of 30. And root 3 is always going to go with tangent of 60 because it's the bigger of the two angles, and 30 was the smaller of the two angles. But this is how you would memorize, or at least be able to get the trig functions of the special angles here. Now there are two angles I did not put in. We say 0 degrees and 90 degrees. But I am actually going to fill these in just as a matter of, supplementing this. But let's go with like a green. But we say the sine of 0 is going to be 0, and the sine of 90 degrees is going to be 1. Okay, these are things to memorize here. Cosine of 0 would be the same as the sine of 90. So if the sine of 90 is 1, the cosine of 0 is 1. And the cosine of 90 would be the same as the sine of 0, since 0 and 90 are complementary. So this is going to be 0. So you notice basically sines, they go in increasing order. You could even say this. You could say over 2 if you wanted to. But basically we say 0 over 2, 1 over 2, 2 over 2, root 2 over 2, root 3 over 2. And then this one right here, I do want to comment on this. It's actually root 4 over 2, which is this. It's 2 over 2, which is 1. So remembering these isn't so bad. Okay, getting those down. As far as tangents go, we just need to know that the tangent of 0 is 0, and we need to know that the tangent of 90 is undefined. So those are the special values of the special angles. They're the trig values of the special angles. So make some flashcards and quiz yourself over these. Maybe on the front, just put the sine of 30 degrees and say, well, what's the sine of 30? Well, wait, sine in my table was the first row, and I know 30, 45, and 60. They were all over 2, and this was the first one, so I say 1 over 2. Okay, so cool. So quiz yourself. Cheers.